Hi everyone. In today's lesson, we'll be taking a look at how to determine the zeros of a tangent function. So in your notebooks, please put down today's subtitle, which is Find the Zeros of a Tangent Function. Finding the zeros of a tangent function is extremely easy. Each series of S-wave crosses the x-axis only once in the cycle. Therefore, we only have to worry about finding one possible angle per cycle. With that being said, let's jump right into an example. Suppose that in this example, we want to determine the zeros of the function y equals negative 2 times tan of half times x minus pi over 3 and then plus 1. As usual, in order to determine the zero of any function, we set the value of y to 0. Next, we'd like to isolate the actual tangent function by itself. So in this case, we move over the positive 1 and the negative 2 to the other side of the equal sign. Next, in order to determine the possible angle that can produce a tangent value of a half, we need to use our calculators. Doing a bit of side work, we do the inverse tan of a half, thereby giving us an angle of 0.4636 radians. After we determine our possible angle, we go back to our main piece of work. We can now say that half of x minus pi over 3 gives us that possible angle of 0.4636. Next, we continue isolating the value of x, and in this example, when we're done, we should end up with x is approximately 1.9745 radians. In order to provide a conclusion in which this value of x is repeated upon every cycle, we'll need the period. In a tangent function, the period is determined by the calculation pi divided by the absolute value of b. And in this example, it will give us a period of 2 pi. And with the period, we can provide a final conclusion that, in this example, the zeros will occur at approximately 1.9745 plus 2 pi n, where n is an integer. And that's all there is, ladies and gentlemen, to determining the zeros of a tangent function.